All right, the last thing in this stoichiometry unit is percent yield. All right, so the percent yield is kind of like a grade of a reaction, and if things go really well, what would you expect your percent yield to be in a reaction? 100. Okay, if you're over 100, that's kind of a problem because that means you violated the law of conservation of mass and you've made air quotes new stuff, and no, that shouldn't happen. So the percent yield should be 100% or less. And if you do get over 100%, that probably means you have some kind of impurity in your sample. Now, the way that you calculate percent yield is you divide the actual amount that you get by the amount that you were supposed to get. So the actual amount is what you weigh out when you do the lab, and the theoretical amount is the amount that you use stoichiometry to calculate to determine how much should you make, and then multiply it times 100. All right, now so here's a couple of examples. The first one is the easy version, which is they tell us that the scientists calculated that she could recover 38.3 liters of oxygen. And then when she did the experiment, she recovered 25.3 liters of oxygen. That was nice because we didn't have to do the calculation, did we? So what would we do to find the percent yield here? Yeah, just do the 25.3 over the 38.3, and then we'll get a percent yield of that. So, and that's where they just gave us the actual and the theoretical yield. So let's do that. You can abbreviate percent yield, percent Y. I'll know what it is. All right, so the actual yield was 25.3 liters. The theoretical yield was 38.3 liters. And then the plan, just tell me the equation you're going to use. Percent yield equals, you can even go A over T, and I'll know what that means. All right, so we're going to plug that in and solve it. We're going to do 25.3 liters over 38.3 liters times 100. Anybody got it yet? 66.5. 66 point, so like 66.1 then. Okay. Anybody second that? Okay, cool. Got a thumbs up. That's good. All right. That's easy. Examples like number 8 are not as easy because this one didn't give us. All right, so they tell us that they recover some copper from the reaction. So the copper that they recovered, that's the actual yield. The problem is that what is this? 2.55 grams of, it's not copper, is it? It's sodium. And then it's reacted with the copper 2 chloride. And that reaction, if you haven't forgotten this anyways, if you react sodium with copper 2 chloride, it makes copper and sodium chloride. And then if you balance it, maybe like that. Okay, so the problem here, they tell me the amount of sodium, but I really need to know the amount of copper. Well, do we know how to calculate that? Yes, we know how to calculate. If we know the sodium, we can calculate how much copper. So that's what we're going to do is in our plan. So we wrote the reaction. And then we're going to calculate the theoretical copper. calculate the theoretical amount of copper, and then we'll do the percent yield thing. Okay. So we got to do that calculation because they didn't give us the theoretical yield of copper in this one. By the way, that's a U, not an A, if you're back in the room squinting. Okay. So let's see. We know that there's 2.55 grams of sodium. And then we can do the stoichiometry. Pretty much every time you have grams of sodium to start, where do you go? To moles. So let's do that. So there's 22.99 or 23.0. All right, so we're at moles of sodium. Then we need to go to moles of copper. So the ratio is 2 to 1. So there's 2 moles of sodium for every 1 mole of copper. The moles of sodium cancel out. And then, let's see, copper, 63.5. All right, the moles of copper cancel out. I bet it's still, 3 point something maybe. 3.58. 3.59. Second on that. Okay, cool. Well, I'm boxing it, but that's not the final answer. Okay, so that's our theoretical. Because that's the amount that we determined by a stoichiometric calculation we should be able to make. We actually made 3.15. That's a pretty good sign as well that this amount is slightly less than this amount. So then we're going to do our percent yield calculation. We're going to plug in the actual 3.15 over the theoretical 3.59 and then times it by 100. Now, the reason why I put this in here is to point out that, if you were doing this, it's grams of copper over grams of copper, so they cancel out, which is what should happen when you're doing a ratio or a percent. If you did grams of sodium over grams of copper, they wouldn't cancel out. So you wouldn't be able to, it wouldn't be right if you didn't convert your 2.55 grams of sodium into grams of copper. So 85% or so. 87.4. 87.74. So 87.7. That's how you do it. And that concludes all of our problem types. And now you should be able to complete worksheet 6 as well.